In this lesson, we will be identifying linear graphs and tables. When we have a graph or a table, we can determine if it is a linear relation. A linear relation is a pattern rule that, when its input and output values are graphed, it creates a straight line. So when I take a look at the actual word here, linear has that word line right in it. So we're thinking about a straight line like you would use by drawing it with your ruler. So linear graphs, we can determine if a graph is linear by determining if it creates a straight line. So all four of these versions here are all linear graphs, and all four of these are nonlinear graphs. So on this one with the green lines, I could use a ruler against any of these lines, and I would know that I could draw that perfectly straight. In this one, they all have some sort of a curve, so that means that they're not a line. When we talk about lines in math, we always want them to be perfectly straight and drawn with a ruler. When we talk about tables, we can determine if it's linear by looking at the patterns within the table. So both the input and the output must go up or down by the same amount in each step. So the first thing we're going to do is we're going to look at all three of these tables and determine how much they're going up and down by in the input and output columns. And then we're going to determine whether or not they are linear or nonlinear. So if I look at A, I go from -3 to -2 to -1 to 0. So each time I move up, I'm adding 1. And on the left-hand side, or the output or y value, I go 9 to 4, so I'm going to subtract 5. And then 4 to 1, I would subtract 3, and then 1 to 0, I would subtract 1. So it changes each time. In B, 5, 6, 7, 8, that goes up by 1 each time. 1, 2, 3, 4, those also go up by 1 each time. And in C, 1, 2, 3, 4, those are going to go up by 1 each time. And 0.25, 0.50, 0.75, and 1.00. Those ones are going up by 0.25 each time. You can think about this one like I'm adding a quarter to the pile of money I have every time. So when I look at these, I want to go back and look at the definition of a linear table. So they go up or down by the same amount in each step. Well, our X column goes up by 1 every time. So those ones are good. So we need to look at the Y column. Now this one changes. I'm going to go down by 5, then by 3, then by 1. So it's going to change each time that I'm going through this. Because this one changes each time, that means that this is a nonlinear table. Now on the next two, on B and C, they go up by the same thing on each side every time. So both of these are going to be linear. Now remember, the definitions of these are a nonlinear. The output or y value does not change by the same amount. So it's changing by a different amount each time. But in my linear tables, the output or the y value is changing by the same amount. I have some practice questions here for you to identify whether the graph is linear or nonlinear, and then a few tables. There is no answer key to this, so if you would like to know if you're doing this right, please take a picture of your work or even just send it to me in an email as sort of a summary, because this is very much just one-word answers, and I can let you know how you are doing.